Assalamu alaikum warahmatullahi ta'ala wa barakatuh. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, let's continue our HVAC tutorials. In this video, we're going to complete our Revit design. We're going to talk about the mechanical settings here. We're going to talk about the systems. We have covered the architectural design in the previous tutorials. So now we have the building. This is the 3D, make it realistic. So we have here our building, and now we have to prepare the building to draw the systems for the ducts and the other HVAC or the plumbing electrical design. So we're gonna in this tutorial talk about the mechanical settings. Note that you can get the mechanical setting from this. It's the opposite of the mechanical settings dialog. To use the mechanical settings dialog to specify default duct and pipe settings. These settings include available sizes, elevation offsets, and slope values. You can also adjust the air and pipe fluid parameters such as temperature, viscosity, and density. And also before this, you can go to manage and open the project units. This is the common, this is the length in millimeters, and the other units, and here is the decimal symbol per digit grouping. But for HVAC, you have to make sure that you use the recommended units. At 90% or more, we use the British units for the density, friction power, and the velocity. It has to be in foot per minute. Click on it, foot per minute or feet per minute, or you can change it to meters per second, centimeters per minute, but it's recommended to use it per foot per minute. And also the duct size in inches, fractional inches. Okay, to the nearest. Okay, also you can use the this settings. Can click F1. Here, if you create a label with length, area, volume, and angle, number, currency, or slope parameter, you can format the appearance of the parameter. So in the edit label dialog, choose the length or area parameter such as a room area, and click this, and the format dialog displays like this. So the use project settings option is selected by default. This means that the value is placed according to the units sitting in the project. And so on. You can see that you can change the format onto the nearest. Okay, we're gonna cover this or talk about this during the work itself. And here the airflow, it's gonna be in CFM, the cubic feet per minute. You can change it, and here is the how you can see it, and everything you need here. You have to check it out before working. Okay, then click OK, and let's open the ceiling of mechanical 1. Notice that we have here a suspended ceiling gypsum board, and go to the systems, and click on mechanical settings. You can click it from here, mechanical settings, and here's the electrical settings, and it's open. It opens, and here is another scenario. So click on mechanical settings. You're gonna here find here the hidden line. So draw map hidden lines. What does this mean? Okay, let's talk about this. Suppose that you wanna draw a duct, and here is the offset 2000 millimeters. Okay, click cancel. Notice that we are in the ceiling number 1, and I'm gonna use another duct. The offset is 2900 millimeters. Cancel and cancel. Look, this is the lower duct and this is the upper duct. Notice that we have here dash lines because we are in the ceiling number 1. So click on mechanical settings and check this. What's gonna happen? Oh, you find this that when you are in the ceiling mech number 1, this is the lower duct and this is the upper duct. Make it wireframe. You will see it like this, and check it. Okay, no changes. Okay, so this is very important to know or to know the how to read the drawings or the method of drawing the drawing. Okay, you have to know to ask your senior engineer what is the right thing to do, what is the method you follow, okay, to make it easier. And if we're gonna make it hidden lines again, okay, you find it like this. So let's go to level 3, ceiling level 3, and make a duct for the same offset and another duct at this offset. I'm sorry. 3000 to see it. Also notice, so this is the higher and this is the lower. Okay, go to ceiling mech and draw the duct. Draw a duct 3000 and another duct. Oh, I'm gonna will not see it due to the visibility range. Okay, make it 1000. Yes. 3000. Okay. Okay. So this is the 3000 and this is the 2500. make it hidden lines. So here the settings, you can hit duct system and then specify hidden lines or ducts. You'll find the hidden lines here and everything you need. So suppose that, okay, here you have here in mechanical one, this is the ground. Suppose that you draw a duct 3000 millimeters height or offset, and here the 2400. You'll find here that the dashed line is for the lower duct. Okay, it's for the lower duct. This from the ground. Okay, go to the ceiling, and the ceiling you can see the view range. Here is the ceiling, maybe make it 1000, make this okay. Okay, change it. Okay, you have to change this. And view depth. Okay, this is not right. Okay, cancel. Control Z. Okay, here we go. This is this view range. This is okay. Here is the offset. Oh, okay, the offset make it 0 to not to avoid seeing anything like make 1. Okay. So this is the 3000 millimeter height, and here is the 2004. Notice that the dashed line now is for the higher or for the higher open make one. Notice here the dashed is for the lower open ceiling, the dashed for the higher. So gentlemen, according to the view ranges, according to the plan you are in, okay, the dashed line is different. Okay, so ceiling make product here, ceiling make 2000. Okay, like this, and another duct is like this. Notice what will happen. Oh, right. So this is the 2000, and this is the higher. Notice that the dashed line is for the higher. Okay. So this is the view range. If you go to make 1, you'll find here this duct is for the 2000, and here no dash for the 2700. Okay, so it's according to your way in drawing. let's delete. Okay, now so this is the line style. The line style here, click on the value column and select a line style from the drop list that determines how the lines of a hidden segment display at the point where the segments cross. So you can use a MEP hidden or thin lines or wide lines, insulating bearing lines. According to the drawing you use, you have to set the type of the line style of the hidden lines. Okay, it may be center line or beyond or area boundary. Anything you need here is here. Okay. So for mechanical equipment or HVAC or the ducts, it's gonna be MEP hidden. Okay. For the inside gap, suppose that you have here a duct and another duct like this, and we are here in, this is the course. So the course or the medium, so this is the medium. So we're gonna here talk about the gap. Okay, for the inside gap, the inside gap means the gap between the dashed line, the inside dashed line, make it, suppose that is 1 millimeter, and click OK. Notice that the gap increases. Control Z, and here make it 0.1. Okay, so it will be it varies. Okay, make it for 0.4, and the outside gap is, this is the, if there any there's line, but the outside I'm gonna make it 1 millimeter. It's gonna change. Okay, this, so Control Z, and also for the single line, if you are in the single line, make it coarse. Also you will find the same. Inside the gaps, make it 1, click OK, increases, and if it is 0.4, it's gonna be like this, and maybe 0.1. This is very important because this will show the final drawing, okay, before printing the project. Okay, now we are in the duct settings. Okay, now for the duct settings, use annotation scale for single line fittings. Yes, check it. You can open F1 also. Okay, the duct settings. Okay, here is the duct fitting annotation size. This is the size that you want, and here the air density like this, and you can change it. Aerodynamic viscosity and rectangular duct size separators cross. What does this mean? Means that you have here 2 ducts, okay, and where is annotate? Tag by category. Okay, notice here that we have 12 inches cross, 12 inches. Click cancel, cancel, go to systems and open here, make it something like this. Okay, find it like this, Control Z. Suppose that you have here the rectangular duct size suffix maybe inches. Okay, you find it inches, anything that you want. Okay, and also the duct, yeah, for the rectangular, this is separator and this is suffix. Also for the round duct, make a duct, but this duct is round, an oval, round duct. This is a duct, round duct. Go to annotate, tag by category, and find it something like this. You'll find here 12, but you have to see the phi to tell you that this is a round duct. This is the phi, okay? Prefix round, okay? Something like this. You can type anything that you want, okay? Okay, this is for the this, and here the oval duct size separator. Also you can say you can fill anything that you want. The duct rise and drop annotation size, if you use these things you can change it as you want. Filling angle, use any angle. Revit will use any angle supported by filling content. Let's say that you wanna draw a duct, this duct, okay, this rectangle duct, something like this, and you wanna go to any angle you want, okay. Notice that you are free, even the 90 degree, like this, like this, like this. Notice, okay, and like this. So it's not a problem for you to use this settings of this type. So that you have another duct like that. Okay, now you can use this. Oh, you cannot here. Here you cannot. You have to go and make it like that. Okay. So it's you here. You are free. But what if you make it use specific angles? So if you wanna use specific angles, gentlemen, Revit will only use these angles, these standard angles. If you wanna follow this, you can make this. Notice that you cannot use the 90 degree. Here the vertical. Okay, here. Okay, it's okay for the rectangular. This duct. Angles. suppose that you have this duct. Okay, gentlemen, I checked it out again. You can also here open make sentence. Here you cannot uncheck or uncheck the 90. Okay, you can use it, but if you don't wanna use 60 degree or 22, okay, here look. Okay, 90. Okay, 45. So it will be according to specific angles only, like this and like this. Okay, all that you cannot hear. 45, 31. Revit will choose the appropriate angle without selecting the if you uncheck an angle, Revit will not use it. Okay, so you can make it, or you can set an angle increment, make it 25. Use duct. Okay, this is the increment here. Okay, like this. Also, you can see that you have the increment. Find snap, sync, snap increments. Okay, the angles. So you can you have to check out every setting here before drawing to know what's going on. The angles. So make it 1. We'll use the increment to determine the angle values every 1 degree. Here, so the angles pane allows you to specify the fitting angle that Revit will use when adding or modifying cable tray or conduit. The settings for fitting angles can be copied to another project using the Transfer Project Standards feature. So if use any angle, or if it will use any angle supported by fitting content, set angle increment specifies the angle increment that Revit should use to determine the angle values, or use specific angle specifies angles that Revit should use. Okay, as we said. Okay. So now. Okay, use any angles recommended for the ducts. To use any angles, we will talk about the pipe settings later, and it's not recommended to use any angle for the pipe. It's not recommended to use any angle. Okay, the conversion here is the default system. What is the default system classification here? This for supply, the duct type is gonna be rectangular. Here you can set the default, okay, and the offset. So here the rectangular duct radius elbow tees. It may be round and okay, click OK and see what will happen when you hit duct. Okay, here, so this is a supply. Hit it again. produce the branch, also make it around duct and 1000. Okay, so this is not this will not work for the normal system. This is only for the generate layout. I'm gonna we may talk about it later. So here we can use the LX specify parameters that control the elevations, duct size, and other characteristics for the duct work created for the main and branch segments when using generate layout only. So click on generate layout. We're gonna cover this in the next tutorials. So whenever a system is selected in a plan view, you can use the generate layout tools to specify slope and routing parameters for ductwork and piping, to view different layout solutions, and to manually modify layout solutions for the system. We're gonna talk about this in the next tutorial, I think. Okay, so here for systems. So the conversion here, the default is for the generate only, okay? And here you can set the offset, and we're gonna cover this later. So for the rectangular here, you can set the size of the things you wanna used in size less or used in sizing. Okay, for example, you wanna draw a duct like this, so you can see here width, you'll find the 3 inches, but I do not see 2. So go to systems, HVAC, and rectangular. You can make new size 2. Okay, click OK, and here's the duct. You'll find 2. Okay, also you can find 2, or you wanna delete it. Okay, so delete size or shoot size 2. Okay, also for the oval, you can check or uncheck what you want, or add new size 12. I don't wanna 12 in the oval. So this oval, okay, go to systems, okay, you can delete the size. Okay, let's draw. So this is the oval, 14. Okay, 11. Okay, you will find 12. I think this is the standard here, but I'm not sure. So suppose that in this round and oval, you uncheck 13 or 15. Okay, here, notice that here you will not find 15. Okay, you have to type it. Go to measure, distance, 15. Is 381. Okay, so Gentlemen, this is it's only to make it easier for you when you draw the sizes. If you wanna 15, if you don't want it, but 12, I think this does not work. So this oval, check it to make it appear. All right, 12, and then we'll find 15 again. Okay, like this. Also, open systems. So you can here set the rectangular, check or uncheck what you want. You can add new sizes or delete size for oval and round also. Okay. Here also for the calculation, the duct straight segment pressure drop calculation here. This is the calculation method that Revit use. Okay. This is for turbulent flow. This is the F dash for laminar flow, and here are the equations that Revit uses for round duct or rectangular duct and the hydraulic diameter. So you can check out everything you want: laminar, turbulent, ranges. Okay. So this is the calculation method, and here another equation for the transitional and turbulent flow. So this is the round, rectangular, and oval. You have to cover these basics, okay? Because you may use the manual methods in calculation, and here are the equations. So you can select the calculation method for the laminar flow and click F1. Okay. So these methods are different. Okay, so here the pressure drop, Revit computes pressure losses, pressure drop calculation in piping based on the geometry and roughness of piping. So this is the for piping, and also in a for, so we can see here for piping this, or the same way you can set or see what's going on here. So this is the calculation method. You can select the method for turbulent flow and for laminar and the transitional. This is the method, and another method also here for transitional and turbulent, and for laminar 64. Notice that for laminar, okay, for transitional here f equal 0, and for turbulent this is the empirical equation for laminar 64 divided by Reynolds, and here laminar also, and here is another, and here for the transitional and turbulent Revit we're gonna use are gonna use this, and here for transitional and turbulent, and here for turbulent only, and for laminar f equal 64, for transitional f equal 0. Okay, so gentlemen, you have to know the appropriate method you want and select it. Click OK. So gentlemen, ladies and gentlemen, this is my tutorial. You have to know these settings because it's very common that the engineers do not use or do not check out these settings before drawing, and they face a lot of problems during the main drawings or the during the design process. So please cover this, read about what you want from Google or the help, check out the YouTube tutorials to cover more and more. The next tutorial for loans, we're gonna start drawing our ducts system here in the 3D. We are gonna use Revit to draw the ducts, and then we're gonna use AutoCAD to check out the settings like or the methods of drawing the ducts in AutoCAD 2D, not AutoCAD MEP, and then we're gonna complete our project in Revit. Thank you very much, and I hope this helps you. Wassalamu alaikum warahmatullahi ta'ala wabarakatuh.